There have been a lot of thoughts exchanged over the past 2 days to say, where is the money really going? Does it make sense? So let's get into how a venture capitalist thinks of where to put his money. So I would like to invite Vedant Agrawal to walk us through how VCs make their investment decisions. Vedant is a product of IIT Madras and has an MBA from Harvard Business School. Thank you.
Good morning, everyone, and thanks so much for coming down for this wonderful conference. The topic of the presentation today is strong conviction weakly held. As the introducer said, essentially we're a VC fund at Premji Invest, and we're responsible to have very strong conviction in the investments that we make and in the areas that we invest in. But at Premji Invest, we take a slightly different take to this. We say, hey, we need to have strong conviction. That's obvious as an investor. But at the same time, you need to hold it weakly. And over the next 15 minutes or so, I'm going to walk through why we believe this is an important approach. And I'm going to take a real-life case study to bring this all to life. Before I get into the meat and sauce, just wanted to introduce Premji Invest. You're probably somewhat familiar with the name. Mr. Premji is the founder and chairman, ex-chairman of Wipro. It's a very large GSI, as many of you are familiar with. What you might be less familiar with, however, is that about 25 years ago, he decided to give away most of this wealth to charity. And so he set up an endowment, which is today valued at about $25 billion. It's the 7th largest endowment in the world, larger than even Princeton. And its sole responsibility is to do philanthropic work in India. They run a network of schools and hospitals. They distributed 11% of India's COVID vaccines. They've written the national curriculum for teacher training in the country. It's a massive social impact. We're Premji Invest. We started about 15 years ago with the idea of taking money from this endowment and investing it in the best financial assets that we could find. And so we invest from Series A to pre-IPO. Our smallest check is $1 million. Our largest check is $100 million. And we invest in enterprise software and healthcare. We're investors in companies that you might be familiar with, including companies like Anaplan, Coupa, Zora, MuleSoft, Icertis, Sysdig, Signified, Outreach, Canva, Navan, and so on and so forth. We're also fairly large, and we manage about $16 billion in capital. I lead the early stage investing arm at Premji Invest, investing in Series A and Series B companies. I'm a graduate of IIT. I graduated in 2016 from IIT Madras. I worked at McKinsey and then Sequoia in India, now called Peak 15. Did my business school at Harvard Business School, and then came over to Premji Invest right after. We've made a few AI bets so far. The snapshot of these 12 companies, some of them you might be familiar with. It's a mix of infrastructure as well as application companies, including companies like Ryder, Poolside, EvenUp, Hippocratic, which is also a General Catalyst portfolio company, Runway, and so on and so forth. Let me get to the meat and sauce of this presentation. And so as I mentioned in the beginning, you need to have strong conviction as an investor. And there's various ways that you can gain conviction. You can look at the TAM, the quality of the founder, the competitive landscape, and so on and so forth. But why is strong conviction really needed? It's needed to really be an effective board member. If you don't have strong conviction, your enthusiasm about a company is going to change basis quarterly results. It's going to change basis what you see on LinkedIn or Twitter or what you read in the news, which is a terrible experience for everyone involved. But at the same time, you need to hold this conviction weakly. And this is an important point, and I want to spend some time on it. There is subjectivity here. By no means am I saying that you should be stubborn and you should not be willing to change your mind. But at the same time, I'm not saying that you should be changing your mind week on week. As an investor, and every investor has to go through their own process of self-discovery here of how much data do I need to change my mind, and how frequently do I consume this new data in order to change my mind. And this is something that we at Premji Invest do every week in our partner meetings, looking at new data, looking at our thesis, and seeing if there are gaps and if we should change. As I said in the beginning of this presentation, I wanted to take a real-life case study to bring this all to life for you guys. And so about 2 years ago, we looked at this category called inference optimization. And so for everyone who's not familiar with this category, essentially, it's a class of companies that serve products that help you as a model developer, as an application developer, run your models cheaper and faster. And so 2 years ago, we said, man, this market, completely uninvestable. We would not touch it with a 10-foot pole for a couple of reasons. One, yes, obviously this market is large, right? Who would not want a product that helps you run your models cheaper and faster? But we said there's inherent problems with this market. One is it's not a durable revenue market. It's something that we call low-calorie revenue, which means that as quickly as the revenue goes up, it'll come down because products are relatively undifferentiated, switching costs are pretty low, and so customers basically move from one vendor to another. What that also leads to is that profit pools are squeezed because the only way a vendor can actually keep a customer is by reducing price. And so it is a price race to the bottom and margins shrink. In fact, we thought the market actually resembled this Dilbert cartoon that you might have seen a couple of years ago. I'll give you a few seconds to just go through it. But essentially, everyone's captured in a price war, and margins are rapidly shrinking to the bottom. The couple of other reasons that we had very strong conviction that this was a completely uninvestable category were the following. The hyperscalers were armed and dangerous. Now, if you've read any business theory from Clay Christensen, who was a professor at Harvard Business School, he says, or he has this theory of saying that in a competitive landscape, the player that is most incentivized to win is probably going to win because they have the ability to move resources within their organization in order to capture most value. And so in this particular market, that player was the hyperscalers. If you take an Amazon, for example, they've got Bedrock. You've hosted a bunch of models on Bedrock. They're most incentivized to create a great inference product so that you can use the models, as well as use all the other value-added services that Amazon provides, database services, networking, storage, compute, you name it. So we were looking at this and saying, man, why would we go up against a well-funded, aggressive, and highly incentivized competitor? It was a complete non-starter. And the last reason was that there were way too many competitors in the market, or way too many players in the market in inference optimization. There were more than 24 of them. All of them were invested by our peers up and down Sand Hill Road. And it was impossible to pass through the signal from the noise. How would we make our investment? Would we make it on the back of a good team, a better product, better traction? It didn't feel like we were actually making an investment, but we were actually making a bet. And we were not in the business of making bets. And so we looked at this market. We said, we have high conviction. We're not going to make the investment. And in fact, we thought of this very similar to MLOps. You would have remembered 5, 6 years ago, MLOps was the rage. Lots of VC funding flowed into the sector, and really nothing came off it, and a lot of people lost money. Now, fast forward to 2025, in about 2 years, a few things had changed in the market. And this slide talks about the 4 things that changed, but by no means was this a simple slide that someone just presented to us. It happened gradually over a period of time. One was models were getting smaller. Now, you would have remembered from earlier this year the DeepSeek moment. Now, what DeepSeek basically said was that, hey, you can have a small model which is custom built or trained really well, and that can perform as good as your state-of-the-art model from OpenAI. And so that caused NVIDIA's market cap to temporarily take a dip. The other thing that DeepSeek taught you is that if you have a small model, the grip that the hyperscalers have on the market, the concept of data gravity, actually goes away. The reason that is the case is a smaller model requires less memory to store. And so as an enterprise, I can take my model, I can train it on all my data that is present in AWS, and then once it's done, I can take it out, and I can go run inference wherever I want. The second thing that was changing is that the architectures for these AI applications itself were becoming very complex. So gone were the days where you had a simple RAG application where you had an LLM, you gave it a bunch of chunks, it reasoned over it, it gave you an answer, you call it a day. In fact, architectures now became so complex that for one query, you were calling 20 different models. You had a planning model, which would figure out, OK, what do I need to do for this particular task? You had a bunch of agents that it would spawn up that would go do some research. Maybe it had a vision transformer that would look at something on a browser. Then you'd have another model called a reflection model that would look at everything and say, hey, have I completed the task or not? Should I redo the task, and so on? Then you had a bunch of embedding models for RAG, and so on and so forth. The explosion of complexity was pretty startling. And so what that happens, or what that means is, you have now multiple points of failure in your system. And for each of these deep neural networks that you call, you need to ascribe compute. And it's almost like a manufacturing line. You need to ascribe compute to each of these different systems so that all the systems work in parallel, and you end up with the lowest possible latency at the lowest possible cost. This is actually somewhat analogous to CI/CD from about 15 years ago, where you had an explosion in complexity, you had environments somewhere, binaries somewhere, different testing that you needed to do, and you needed an orchestration on top of all of this to bring it all together. The third thing that changed is that the winners were emerging, which was kind of obvious, right? In any market, over a period of time, some companies will shut down, some of them will get acquired. We felt very good that we were not part of some of those companies that shut down. But the more important read-through here is that the winners that emerged actually had surprising economics. And that was because they were serving companies where inference was actually a mission-critical product. It was in the critical path, it was serving an end customer, and so you needed 3, 4, 5 nines of reliability in order to make this work, which gave then the vendors of these companies, of these customers, pricing power. And the last part is that relatively simple applications were still driving massive ROI. The way I like to characterize AI applications today is really the flashlight era of applications. You folks would remember when the first iPhone was released, you had very simple applications, right? You had a flashlight app, you had a beer app, you had an app where you touched it and there was a whip sound that came out. That's really the category of applications that we see today. The Uber moment for applications, an application that truly takes all the developments that we've seen across models, data engineering, ML ops, and so on, is still a couple of years away. And so we said, man, if these simple applications are still seeing such massive ROI, what happens when you actually have the Uber moment for applications? Inference was bound to explode. And so we had these new data points, but we didn't change our mind as quickly. We said, okay, let's think through this a little more. And the couple of questions that we had to ponder over is, yes, maybe this market is a little larger, but can it support multiple billion-dollar players? Because there was still a few number of players in the market. Do the hyperscalers have a structural disadvantage? So hyperscalers are still very, very incentivized to win, but is there something that prevents them from winning? And the third is there any way at all that you can lock yourself out of a price war? And so we took this, we went and met a bunch of other companies in the category, and we came back with a renewed thesis. Renewed thesis was something like this. We said, yes, this inference market is unbelievably large. You're in the flashlight era of apps. It's going to get more complex. For some of the customers that we spoke to, inference was actually the second largest cost driver for them, which was huge. And the real linchpin for all of our thesis now was reliability. So as I said earlier, some of these workloads now were in the line of, it was in a mission-critical path, which basically meant that they were end-consumer facing. They were not similar to your batch inference workloads that you were trying to do with recommendation systems where, yes, it could be a few seconds delayed, it cost a few extra dollars, and that's fine. These were customer-facing. Every millisecond of latency mattered. Every dollar of cost mattered. And so customers on the other end, which are using these products, were saying, hey, if you can demonstrate high reliability for me, 4 nines of reliability, then I am very disincentivized to take you out and introduce you with anyone else. The second is, yes, the hyperscalers are armed and dangerous, but there was enough data to show that the hyperscalers' products were absolutely terrible over the last 2 years. And reliability, again, played a key role here. Now, if you're a customer, and I have a mission-critical workload that is serving my end customer, I need to be multi-cloud. I can't rely on just one cloud just because my data is there. You will all remember a couple of months ago, Google Cloud went down, and a lot of services were impacted because of this. It's completely unacceptable to have that when you have these new class of AI applications. And so actually, inference is the tailwind towards a multi-cloud world. The other reason we thought that hyperscalers were completely inept at building a product here is because it was a primitive that they were just not used to. A good product here is not simple. It's actually fairly complex. You need an excellent developer experience where you could do like a data robot, data IQ type product where you test models, create models, roll them out. It doesn't work, you roll it back. Not only that, you also need a great inference runtime. So you need a product that can quantize, prune, do speculative decoding on your model so that it actually runs faster with the same level of efficacy. And in addition to all these two things, you also need infrastructure where you need to scale up and scale down at will, be multi-cloud, and so on. This is not a primitive that any of your hyperscalers today are used to. And the last point was, yes, winners were emerging, but the more important point there was that some of these winners said, hey, we're not actually just purely GPU reselling. So they didn't have gross margins that you would think as 10%, or they obviously didn't have 80% software gross margins either, but they were pretty healthy and they were trending up. And the key point there was, hey, you don't need to use my compute for your inference. I will meet you where you are, and I will build a pure software product for you, which is very, very interesting for anyone who studied how enterprises buy. And so the result, we did a complete 180 in our conviction. We had very high conviction that initially that inference was completely uninvestable. We saw new data, and we did a 180 degree. And we invested in a company called Base 10, which we felt was by far the best company in this category. It was a very large round. It was a $150 million Series D at a pretty high valuation, which kind of showed the amount of conviction that we had in our renewed thesis. And so strong conviction, weakly held, is really one of the pillars in which that we at Premji Invest use when we make investment decisions. And I'll leave you with this quote by Charlie Munger. If you're not willing to change your mind, you're going to make a lot of mistakes. Thank you so much for your time.